So far we have learned about vectors, and we have learned how to add any two vectors. We have also learned how to resolve a vector into two components. Now in this lecture we shall learn how to multiply any two vectors. So there are two types of multiplication of vectors. So one is called scalar product, and another one is called vector product. So let us take first the scalar product. Now if we have two vectors a and b acting at a point, so we have two vectors, say this is a vector and this is b vector, and they're acting at a point, and say the angle between these two vectors is theta. So two vectors a and b, and the angle between the two vectors is theta. Now the scalar product is defined or can be defined as a dot b, and this is equal to a b cos theta. So this is how we can define a scalar product, or it is also called a dot product. So we have a dot b, this is equal to ab cos theta. Now a is the magnitude of the a vector, b is the magnitude of the b vector, and theta is the angle between the two vectors. So this is the scalar product of two vectors, or we call it the dot product of two vectors a and b. Okay, so where a is the magnitude of the vector a is the magnitude of a vector, and b, this is also the magnitude of b vector, and theta, this is the angle between a and b, angle between the a vector and the b vector. Now let us consider two vectors represented in terms of their rectangular components. Okay, suppose we have a, this say is equal to 2I cap plus j cap plus say 3k cap, and the b vector say is equal to 3I cap plus say 4j cap and plus k cap. So we have two vectors, a is this one, b is this, and say we'll have to take the dot product of the two vectors. Then we have a dot b, which is the scalar product. Now this is equal to, we have to take first this one, 2I cap plus j cap plus 3k cap, then dot of this 3I cap plus 4j cap, then the plus, I'll write it here, k cap. So a dot b is equal to a dot b. Now in this dot product, we'll have to multiply this, or take the dot product of this vector with this, this and this. So we have 2I dot 3I. Now the magnitude of these vectors, okay, can be multiplied as usual. That is, we have 2I cap dot 3I cap, then this 2 will be multiplied with 3 will give you 6, and these unit vector, you can take the dot product of these. So I dot I. So now we have 2i cap dot 4j cap. So this will give you 2 into 4. Then you have I dot j. And again you have 2 dot k. So you have plus 2 I cap dot k cap. Means 2 into 1 will be 2. So here dot k cap. Now these dot product I dot j and I dot k, these will be equal to 0. Since if we take the dot product, I'll show you here, I dot j, this will be equal to, what is the magnitude of a unit vector? 1. What is the magnitude of this j cap? This is also equal to 1. So 1 into 1 cos of theta. Now what is the angle between I and j? Since I is along the x-axis, j is along the y-axis, I'll draw it here. So this is your I cap and this is your j cap. Since the angle between I cap and j cap, this is 90, so you have cos of 90 degree, and cos of 90 degree, this is equal to 0. Hence your I dot j, cos of 90 is equal to 0. So I dot j, this will be equal to 0. So here I dot j will be equal to 0. Even this I dot k also, okay, k is along the z axis. So the angle between, if we draw k vector, will be in this direction. So this will be your k vector. So here again the angle will be equal to 90. Okay, so the angle between I, j and k, I and j is 90, j and k is 90, and I and k is also 90. Hence if we take the dot product of ij, ik, this will be equal to 0. Hence this also is equal to 0. This will be equal to 0. Hence 2 into 0 is 0. This also will be equal to 0. So 8 into 0 will be equal to 0. So what you left is with I dot I. So here I dot I dot I. This will be equal to 1 into 1 into cos. What is the angle between the I and I? Since I and I, they are in the same direction, the angle between them is 0 degree. So cos of 0 will give you 1. So hence 1 to 1 to 1, this will give you 1. So I dot I, this will be equal to 1. Okay, so here this 6 will multiply with 1, so we'll have 6. Okay, so how we get this? By taking the dot product of 2i with 3i, 4j and k. And remember that I dot j 0, I dot k is also 0. Now similarly with other vectors also, with this also, you will have to take the dot product of this one with all the vectors. But since we know that j dot I will be equal to 0, since they are different, and j dot k also will be equal to 0, we only left with this j dot 4j. So here also no need to take this j dot 3i and j dot k, because we know it is equal to 0. Hence we just take this j and this j component. So j dot 4j, this will give you 4. J dot j, again j dot j will be equal to 1. Since they are same, the angle between the j and j is 0. Hence this will be equal to 1. And similarly with this 3k vector, 3 cap also, this also just take the dot product of 3 cap with k cap itself. So here we have 3k dot k, this will give you 3 k cap dot k cap. Again here k cap dot k cap, this will be equal to 1. Hence we have the following: 6 plus 4 plus 2 will give you 13. So here A dot B is equal to 13. And do you see any unit vectors in this result? No. Since there's no unit vector in the result of A dot B, the dot product of these two vectors will give you a scalar quantity. Hence we call this as the scalar product, because if we take the dot product of these two, you will get a scalar quantity. Okay, so for simplicity, if you have to take the dot product of two vectors, okay, what you do is no need to give these expression also. So you have A and B vector given in terms of the unit vector or the rectangular components. So what you do is, you have A dot B, you have two vectors, you just multiply 2 and 3, 6, 1 into 4, 4, 3 into 1, 3 into 1, 3. You'll get this as 13. Okay, so just multiply the ith component, the jth component, and the kth component. You'll get the dot product of the two vectors. Okay, so here remember that I dot I, this will be equal to 1. Similarly with j dot j and k dot k. So all this is equal to 1. And if we have I dot j, this will be 0. I dot j, this will be 0. Similarly with I dot k. Similarly with j dot I. Similarly with j dot k. And also with k dot I. And then k dot j. These all will be equal to 0.